Okay, a few more problems. In any triangle, if you have two sides that are not equal, or three sides that are not equal, then the larger of the angles, if you're only comparing two angles, it would be the larger of the two angles that you're comparing. The larger angle is always opposite the longer side, and vice versa. So in this case, if we have three unequal lengths, 12, 13, and 14, the largest angle is going to be opposite the longest side. So obviously 14 is the longest side, so we go across the triangle, and angle B therefore is the largest angle. If we find the shortest side, which in this case is the 12, and we go across the triangle, we're pointing at angle C, so angle C has to be the smallest angle. And as I stated, conversely, if we have two angles that are 58 and 65, we add those together, we get 123. We subtract 180 minus 123, and we get 57 for the other angle. Now if we know all three angles are 57, 58, and 65, the smallest angle is 57. Across from that, you're going to find the shortest side. So segment RS is the shortest of the three sides. Because the 65-degree angle is the largest angle, across from that, segment ST is going to be the longest side. And we have one more theorem we're going to be going over here. Is it possible to have a triangle with these sides? The theorem, as stated in your book, states the sum of any two sides has to be greater than the length of the third side. Basically what that means is the shortest distance between any 2 points is a straight line, as I'll demonstrate on problem number 2 here. But for now, is it possible to have a triangle with sides of length 7, 4, and 10? So the only equation, or technically inequality, that you have to test, the two shortest sides added together should be greater than the third side, the longest side. So 11, is that greater than 10? And the answer is yes. And now I think when you see a problem where the answer is no, it's not possible, it's easier to understand. You have 8, 12, and 3. I'm going to draw the diagram this way. 8, 12, and 3. So I'll put the 12 down here, the 8, and the 3. So I want you to consider this like a road map. If you were going from town A to town B along a perfectly straight road and traveled 12 miles, it doesn't make sense that somebody could travel from town A out of their way to town C, 8 miles away, and then only have a 3-mile drive over to town B along another straight road. That person traveling along this orange route travels a total of 11 miles, which is less than somebody that traveled on a straight line. So therefore, that can't possibly make sense. In other words, 8 plus 3 is supposed to be something greater than the 12, the distance along the straight line. And 11 is greater than 12? No. So therefore, it's not possible to have a triangle with sides of length 8, 3, and 12. It just doesn't work. For the last one, a lot of people tend to get confused when you have two sides that are the same, because what I stated when we did the first problem, actually each of the two previous problems, I said you want to take the longest side. Well, there's two 10s, so which side is the longest? Either one of them. And take the sum of the other two values, and that sum is supposed to be greater than the side you're saying is the longest. And 11 is greater than 10. So therefore, yes, it is possible to have a triangle with sides of length 10, 10, and 1. It would look something like this. A tall, skinny isosceles triangle, this being 10, 10, and a little segment of 1 joining those two base angles. Hope that helped.